In this session, we are going to discuss about the dependence of resistance of a material on temperature, how the resistance of the material tend to depend on temperature. So tunachokisema ni kwamba electrical resistance of a material increases with the temperature rise. Increase in temperature, increase the resistance from 0 degrees centigrade is given by the relation. So assume now we have the relation at the 0 degree Celsius, which is R theta is equal to R naught, which is temperature at 0 degrees Celsius, 1 plus then coefficient of resistivity, this is change in resistance, then change in temperature theta. So if we are changing the temperature, or if we are expanding the equation, R theta B is equal to R naught, 1 plus alpha theta 2 minus theta 1, theta 2 minus theta 1. So even ndivyo ambavyo resistance inakuwa na change with the temperature. So that means E R naught in resistance at 0 temperature, R theta in resistance at a certain temperature theta. Na kidogo equation hii inafanana kwenye linear expansion, like that is how resistance tend to vary with temperature. Na ina increase with temperature. That is because when we're going to increase temperature, random motion of electron ina increase, and finally zile electrons zinakuwa ziwezi kuflow kama zingeweza kuflow mwanzo. So if we want to solve for the temperature coefficient of resistance of the material, how to get it, we should make this the subject of our formula. Then we multiply our R naught inside, then we'll just make this the subject of our formula. So we'll get the temperature coefficient alpha is equal to change in resistance divided by resistance, not change in temperature. So it is change in resistance by original resistance times temperature rise. So by definition, the temperature coefficient of resistance of a material is defined as the fractional change in resistance by unit temperature rise. Fractional change in resistance by unit temperature rise. The SI unit of temperature coefficient of resistance is 1 divided by Coulomb, or 1 divided by Kelvin. Things are going like that way. Kwa hiyo even ndivyo ambavyo tuna define the temperature coefficient of resistance. From there we can discuss the concept of electrical conductance, G. The electrical conductance is the inverse of resistance, and the unit of electrical conductance is ohm power negative 1. And about the dependence of resistivity on temperature, the equation for the dependence of resistivity on temperature will be similar to that which is for dependence of resistance on temperature, and the equation for the coefficient also will be similar. What will change is simply the definition. The temperature coefficient of resistivity of material can be defined as the fractional change in resistivity by unit temperature change. Fractional change in resistivity, that means change in resistivity divided by original resistivity, then by unit temperature change. Then about the electrical conductivity is defined as the reciprocal of resistivity. So from here we have the solved equations, and let's move together. So in an experiment carried out at 0 degrees Celsius, A was 1.20 meter of nichrome wire of resistivity, this one, and the diameter of this one. And B, a German silver wire, that is the diameter and resistivity, this one. The ratio of resistance A over B was this one. What was the length of wire B? So you are given the ratio from resistance, and then you are asked about the length of wire B. If the temperature coefficient of the nichrome wire is this one, and that of German silver wire is that one, what will be the ratio of resistance if temperature is raised by 100 degrees Celsius? So firstly, you need to memorize about the equation for the calculation of resistance. And as you said, the resistance is equal to resistivity, length divided by area. So resistance 1 takuwa sana, resistivity 1, length 1, area 1. And resistance 2 is equal to this one. Calculating the ratio of their resistance, the ratio of resistance AB. So calculating the ratio of resistance, we'll take the equation for the resistance 1 divided by the equation for the resistance 2. So it will be R1 divided by R2. Then it will look like this way. Resistivity 1, length 1, area 1. Then times area 2 divided by resistivity 2, length 2. So finally we'll end up with R1 divided by R2 is equal to resistivity 1, length 1, area 2, area 1, resistivity 2, length 2. So here R1 divided by R2 is this one, resistivity 1 and this one. Then you are just solving for them. You are just solving for the area 1 and area 2, also for the length of the wire. So area 1 and area 2, area 1 is this one and area 2 is this one. Substituting this into the equation, actually, finally you are getting the very long equation like this one, but you get into the answer which is 1.5 if you substitute the values. Now, using the equation, because you are asked what will be the ratio of the resistance if the temperature is raised by 100 degrees Celsius. So using the equation, R, this one is equal to R naught, then 1 plus C, that one. So we first need to know about the resistance of each one of these wires. So let's let the resistance of nichrome wire be R1 at 0 degrees Celsius and at 100 be RA. So RA will be equal to this one times C R1, because you're already given the coefficient. You're already given the coefficient. Also, let the resistance of German silver wire at 0 degrees Celsius to be R2 and at 100 to be RB. So RB will be equal to R2 plus that change in temperature. So A plus B, that means the ratio of the resistances, it will be, because the change in temperature is known. So the ratio of the resistances, that means taking this times this, you will get this. The ratio of the resistances by a change in temperature of 100 will be so it will be 1.21. It will be 1.21. The second equation, find the electron density, current density, and drift velocity of electron in a copper conductor in a square cross section of 1 millimeter of a side and carrying a constant current of haya ni maswali ambayo tunatumia concept za kule nyuma, na in order to save time I would like not to pass through these questions, ili kwamba if you get time you just pass through them on your own time, lakini ni enda moja kwa moja kwenye concept. You can just pass through this question in the notes and then you can understand everything. Thank you.